Hi, my name is Brian Murray. The title of my project is Research Developments in Hybrid Battery Technology. The key automotive targets are 40 kilowatt battery, full hybrid system example, high specific power, 20 kilogram battery, 30 cold cranking amp capability, 5 kilowatts, extremely high shallow cyclic life, 500 kK cycles, long operating life, 15 years, high power, cost goals of $20, PHEV plug-in type hybrid system example, high energy power battery, 10 kilowatts, etc. Hybrid are some of the hybrid battery goals. Lithium-ion batteries will lead the future. The most widely used hybrid vehicle battery in industry today is a nickel metal hydride battery. Competition between manufacturers is focused on extending the hybrid range. The nickel-cadmium battery, although worthy as a hybrid vehicle battery, does not allow hybrid vehicles to have a range beyond 40 miles like a gasoline-fueled vehicle does. This is because of the limitations in its energy storage ability. The goal of hybrid car manufacturers is to produce hybrids that have more range, thereby making hybrid cars more useful to consumers. Nickel metal hydride batteries have reached a technological peak in terms of what future developments can be achieved. The battery that appears to be on the way to revolutionizing the hybrid vehicle industry is a lithium-ion battery. The problem with lithium-ion batteries was that one of the metals used in the battery was very susceptible to catching on fire if the battery was overcharged. Lithium-ion batteries are the ideal choice for use in hybrid vehicles since they possess a high specific energy and voltage that would allow them to deliver a higher amount of current for a greater period of time than a similar sized battery. Greater energy storage means greater driving range. Looking at the details of the lithium-ion battery, lithium-ion has a 3.6 nominal battery voltage per cell, 766 theoretical specific energy, and 120 practical specific energy weight kilogram. Some of the drawbacks are safety issues, counter life, and cost. Looking at the nickel-cadmium battery, nickel-cadmium has a nominal voltage per cell of 1.2 in comparison, 244 theoretical specific energy, and 50 practical specific energy weight a kilogram. Some of the drawbacks are the materials toxic, cost and memory effect. Here's what the future of lithium-ion batteries look like. The researchers at MIT have developed a new revolutionary type of lithium-ion battery. It's on the way to becoming the cheaper alternative to the battery that now powers hybrid cars. Looking at the details of the Challenger lithium battery, current lithium batteries do not have the rapid charging capability or safety levels needed for use in cars. Hybrid cars now are running on nickel metal hydride batteries which power an electric motor and can rapidly recharge while the car is decelerating or standing still. Lithium batteries have enormous growth potential. To combat the problem with lithium-ion batteries, a lithium-nickel-manganese oxide combination battery has been developed to revolutionize the hybrid car industry. Lithium battery technology explained. The new material is more stable and safer than lithium cobalt oxide batteries that have been used to power electric devices such as cell phones, laptop computers, etc. The small safety risk posed by lithium cobalt oxide is manageable in small devices but makes the material not viable for larger batteries needed to run hybrid cars. Researchers say cobalt is also seen as fairly expensive. The MIT team's new lithium battery contains manganese and nickel, which are cheaper than cobalt. Scientists already knew that lithium nickel manganese oxide could store a lot of energy, but the material took too long to charge to be commercially useful. The researchers set out to modify the material structure to make it capable of charging and discharging more quickly. Lithium nickel manganese oxide consists of layers of metal, nickel, and manganese separated from lithium layers by oxygen. The major problem with the compound was that the crystalline structure was too disordered, meaning that nickel and lithium were drawn to each other, interfering with the flow of lithium ions and slowing down the charging rate. Lithium ions carry the battery's charge so that they maximize the speed at which the battery can charge and discharge. The researchers designed and synthesized a material with a very ordered crystalline structure, allowing lithium ions to flow freely between the metal layers. A battery made from the new material can charge and discharge in about 10 minutes, about 10 times faster than unmodified lithium nickel manganese oxide. That brings it much closer to the time frame needed for hybrid car battery researchers' stated goals. Before the material can be used commercially, the manufacturing process needs to be made less expensive, and a few other modifications will likely be necessary, researchers say. The structure of lithium nickel manganese oxide consists of layers of transition metals, nickel manganese blue layer, separated from lithium layers, the green layers shown in the illustration, by oxygen, which is the red layer shown in this illustration. Protecting the environment with hybrid vehicles. Currently, hybrid vehicles aren't widely accepted, chiefly because of their lack of range and slow refueling time. These limitations need to be overcome if we are to protect our environment through the use of hybrid vehicles. A lithium battery that affords more compactness, more power, and more battery life will power future hybrid vehicles' electrical systems. Expect to see hybrid vehicles in the future with an increased operating range. Also expect to see faster recharging times and a 15-year battery life at a reduction in cost. In summary, future generations of lithium batteries promise to eliminate the difficulties that are inherent in today's lithium-ion batteries. The end.